above the x-axis. So I did did y'all get this? Do you need this one or y'all okay? Got it wrong? Okay, so this is 6. Velocity, it told me that velocity was 6t minus t squared. Wanted to know the total distance traveled from 0 to 3. So I did the integral from 0 to 3 of that velocity, but what I want to do is make sure it's the absolute value here. But because I'm already above, if you know what this graph looks like, right, then I'm already above the x-axis. I don't have to worry about doing an absolute value or anything like that. So I just went from 0 to 3 and did the antiderivative there. Yes, but because they both have a t on them, when you plug in 0, you just get 0. So really, you're just plugging in 3 there. And you get 18. Just minus. Do upper bound minus lower bound. Okay, if it's negative, like if you graph it and it's under the x-axis, yes, you have to change the time. That's why we changed that whenever we did it before. So if it did something like this, right, I would take from here to here, but then I would have to do the negative of this because I'd need it to go back up. Then right. Number 7 was a chain on chain on chain. So you had to do outside, and then you had to do inside there, so it ended up being E. Do y'all need me to do that one? Yeah, okay. That was power, and then inside, and then if the trig had a derivative, we would have done that as well. All right, number 8. Number 8 is the one that I missed because I'm an idiot. Because I didn't read the problem through. This is what I fuss at y'all about all the time, and I didn't do it. The very first, I got so mad at myself, you can tell I was mad because I went back and circled this really dark whenever I figured out I missed it. A tank contains 50 liters of oil at time t equals 4. That means I'm starting with 50 liters. Before anything happens, I have 50 liters in the whatever container it is, in the tank, right? And then I go through all this. So I knew how to do the Riemann sum. The Riemann sum wasn't a problem. The problem was I forgot to go back and add in what I started with because it says how many liters of oil are in the tank at time t equals 15. So you don't know how to, okay. Okay, so I got 4, 7, 12, 15, and I got 6.5, 6.2, 5.9, and 5.6, right? Rectangle 1, rectangle 2, rectangle 3. Everybody agree? Doesn't it say 3? Does it say right or left? Right Riemann sum with 3 subintervals, right? All right, here's one rectangle, but the height is not consistent between them, so I'm going to have to find it. And I did this on mine, so between 4 and 7 is 3. Between 7 and 12 is 5, and between 12 and 15 is 3. This is the width of each rectangle as I go across, right? And then I just take the right side, so it's 3 times the right side is 6.2, plus 5 times the right side is 5.9, plus 3 times the right side is 5.6. And if you do all that, and I have my little addition and long, I guess, lined up like in elementary school. And you will have a couple like this that are non-calculator that you go, oh my gosh, I have to do that. But yeah, you do, unfortunately. And so I got 64.9 and I stopped there and circled it and everything else. I got A on that one and did not read that I needed to go back and add that 50 liters that I started with to come up with the 114. Nice thing about multiple choice is they're not looking at your work. They will not look at your booklet at all. The only thing they are looking at is that multiple choice sheet. So we want to make sure we don't spend too much time trying to show every little step. All right, number 9, if it's continuous, well, if it's continuous, then that hole is plugged at 2, right? So if I mark out that x minus 2, it leaves me with 2x plus 1, and then I've got this k down here. So if that I would need to equal 5 if I plugged a 2 in here, right? All right, let's do 10, Mag says. Clearly I struggled with this one because I have a bunch of scratched out stuff. I got there, but it took me a while. What's the area of the region in the first quadrant bounded by the graph of y equals x over 2 and the line x equals 2? So the first thing I did was sketch it out. I know that x equals 2 is a growth graph, so it looks something like this. I know that x equals 2 looks something like this. I'm not real sure. I don't have to be exact. I just need to know, remember, which one's on top, which one's on bottom, or what I need to do. I made this way harder than it had to be to start with, because really, if it's the area of the region, right, area under the curve is the integral. We all agree? Top curve minus bottom curve, but there is no bottom curve. It's just the area under this curve. So all you do is go from 0, but I do need to know this. Well, luckily, it's 2, of e to the x over 2 dx. I did have to do a small u substitution here. I let u be x over 2, so du was 1/2 dx. So I countered with a 2 outside, from 0 to 2, e to the u du, and whenever I did the antiderivative here, I adjusted these bounds. 0, 2 over 2 is 1. So I got 2e minus 2e to the 0, so 2e. Which one's A? I started doing some crazy crap. I started doing it with respect to x and went through and had a natural. I was off on a. Oh. So if you need a 1/2 in here, then I have to counter it with a 2 out here. All right, 11. Which of the following statements is true? And so we recognize that being a corner or a cusp right there because of that absolute value. So that's what we were looking for. We know that those are continuous functions, but they're not differentiable at those points where it comes down to a corner or cusp. So that was A. 12. 12 even told you what the U was. Do y'all need that one or y'all okay? That was C. Y'all guys speak up if you need it. 12, you didn't get the right answer. Okay, let's look at it. From 1 to 4, it told me to let u be the square root of x. So I'm going to go ahead and do e to the u. du here would be 1/2 x to the negative 1/2. So in order to make this du, I need to counter it with a 2 outside. And now I have to adjust those bounds, right? So when I adjust the bounds, I'm using square root of x. So square root of 4 is 2. Square root of 1 is 1. That's all you had to do there. Because the square root of 1 is 1. I'm plugging into the u equation. Well, normally whenever we do it, we normally do it after we come over here and do the antiderivative, then we adjust the bounds. But technically, they're adjusting the bounds here because once you've replaced that u here, these are no longer x. You don't have an x in the equation, so you really need to replace them there. So that's all they were doing, was showing you that was. What did y'all get for that one? B? Yeah. 13, yay or nay? I didn't get this one either. What'd you say the answer to this one was, Avery? All right, let's see if that's what I get when I work it. It wants to know the integral from 1 to 5 of f of x. So again, I'm going to have to split this one up because I've got this piecewise, right? And the first one runs from less than 3. The second one is greater than or equal to 3. So what I'll do, since I want to go from 1 to 5, I'll go from 1 to 3. And for that one, I'm going to use 2. And I'm going to add that, and then from 3 to 5, I'm going to use x minus 1. Well, remember your properties of integrals, right? If I go from a to b and add it from b to c, that's really from a to c. And since that's what they asked me, well, but it's all the way up to 3. So if you think about the way the integral works, because whatever so this is y equals 2, right, which is this horizontal line. If it goes to 3, so I cut this off here, it doesn't really matter if I include it or not, it goes all the way up to that, and then this one takes over, and then that's going to be the area. So this is going to be 2x from 1 to 3, and this one's going to be 1/2 x squared minus x from 3 to 5. Does that give you the right thing? Apparently that's where I stopped. 6 minus 2 plus 25 over 2 minus 5 minus 9 over 2 5. Where's C minus 3? Oh, thank you. And then, let's see, that's 10 over 2, 15 over 2 minus, this is brutal, 50 over 2, which is 12 over 2, which is 6. 6 minus 2 is 4, and 4 plus 6. This is the kind of crap I get bogged down in when I do. Not the hard stuff, but just stupid calculation stuff when I don't have a calculator.
I did that. What is that? Oh, that's the bar.
14, I kind of went to jumping 14, just plugging one into the other f of g of x, and then evaluating it 3. I probably went about that the long way. I plugged in what you really could have done on this one, and now that I look at it, I see it, but I did not see it this way whenever I took it. It says to evaluate the derivative at x equals 3, so what you really could have done, I plugged in first and then I took the derivative. Is that what y'all did? No? So what you could do, and then chain it. Is that wrong?
I don't even know what I did. I got it right.
Okay, let me work it the way that I worked it because it makes the most sense to me. Just know that you could have done it this way. So I did f of g of x first because I trust myself doing that because I'm pretty good with the algebra part of it. So I did square root of, and then I plugged in g, which was 3x minus 2 squared minus 4. I didn't multiply this out or anything of the sort. I just went straight into deriving from there. So I did 1/2 times 3x minus 2 squared minus 4 to the negative 1/2, and then I moved into chaining it. So whenever I chained it, this is what has a derivative, so I do 2 times 3x minus 2, and then I chain this again, and I get 3. Now, at this point, I went, holy crap, I'm going to go ahead and plug the 3 in, because remember, it asked me to evaluate at 3. So at this point, I literally did this because those cancel. And then I went, okay, I'm going to go ahead and plug into 3. And I do this a lot of times if I'm on multiple choice and I'm not having to justify and show my work and I don't have to follow through. I don't have to have anybody follow me. It's just for me. I'll scratch out and just do whatever kind of work makes sense to me. And I'll do silly little things like this because whatever you can do to save time, you see how crunched you are on time anyway. Anything you can do to save time while still being cautious and careful about what you do, this is definitely worth it. All right, so 9 minus 2 is 7. 7 squared is 49, and 49 minus 4 is 45 to the negative 1/2. Right? Times 7 times 21. I look at the way the answers are formatted. Anytime I get about here, I stop and I look at my answer choices. How are they formatted? Before I do a whole bunch of work that I may or may not need to do, what do the answer choices look like, and am I even on the right track to get there? I saw that every one of them had a radical in the bottom, and I'm kind of in luck because I've got a radical here that's going to be in the bottom as well. So I knew I was on the right track. This is a negative exponent, so it comes down to the bottom, and I went ahead and changed it to a radical since that's the form their answers were in. But that answer is not on there. There are some 21s on there. There are some 45s on there. There's all kinds of stuff, but not this. So I said, okay, maybe they want me to simplify it, right? Can I split that up any? I see a 9 and a 5. 21, 9, and 5, which this is 3. 21 divided by 3 is 7 over root 5, and that one is there. That's just kind of the way my brain works through that kind of problem. Okay, well, if you got the root 5, then you were down to 3 answer choices, which is a 33% chance. So that's better than a 20% chance. And you guys see. So you win some, you lose some. No, I'm just kidding. All right, 15. Did y'all have any trouble with 15? Analyzing the graph. I'm sure you can guess already I have sign analysis all over here because that helps me to visualize. It's hard for me to just look at a graph and determine what it is I'm looking at and what's going on. And so I always guesses. All right, so this. That's intermediate value, Sam. So here, I knew right off, and I've told y'all before on FRQs, this is a lot like the FRQ that you get. Always denote, so you do not lose track of what it is that you're doing. What's the derivative? What's the function? So that you know. I know here that what I'm looking at, because everything is in regards to h here, what I'm actually looking at is a derivative graph. Okay. All right, so it's asking me to order them at a particular point. Only at 6, it's asking me which one's bigger or which one's right. So here's what I did. I said, okay, the derivative tells me what the function is doing. The derivative is f. That's the actual graph. So I'm looking for the zeros of the actual graph. Only happens one time. That's at 6. Right? So h prime of 6, I know, is 0 because that's coming straight off of my graph. It's negative, it's positive, it's decreasing, it's increasing. Derivative. This is the graph of f, but they're asking us about h. So I have to look at the relationship between h and f. It says h of x equals the integral of f. No, that's the graph of h prime of x. That's the graph of the derivative of h.
But I feel like this h of x equals the integral. I feel like I mean
Right. If if you were trying to get h by itself,
what you're saying.
What's the opposite of the integral? A derivative. So if I do the derivative of this side and the derivative of this side, this goes away, and it leaves me with the derivative of h equals f. You see what I'm saying? All right, so now if I think about, and this is where it gets a little harder because The second derivative is, they're asking me about that also. Right now, I can look at what's going on at 6 with the graph. I need to look at what's going on here, the second derivative, which are going to be the max and mins of the derivative, right? That's where it's changing. I think it's on that sheet. Look on that sheet I gave you. If it's not, I'll write some out for you to. The one that's stapled together, I think. I'll dig through. Okay, so if it's asking me to order these two things, these three things. Yes. Where does the slope change? Maxes and mins, right? So it looks like about at 2 and about at 8. Slope is decreasing, slope is increasing, slope is decreasing. So what I'm looking at here, because I don't even need the top part of it, this just helps me wrap my brain around it. I know that at h of 6, or the second derivative here, it's positive. Agreed? What about h of 6? That's the only one I'm left with. If h of x is the integral from 0 to 6 of f, look at your graph. What happens between 0 and 6? It's negative. It's below the x-axis, so that tells me it's negative. So if I'm ordering these in order, well, this is the smallest, followed by this one, followed by this is the biggest. And that's the way these are always going to work when you see them. I've never seen one that didn't. It's never a specific value. It's always one's 0, one's positive, one's negative, and they want to make sure you can determine which one's which. Yep, so h of x, I use that formula. Remember, if they give you a formula, what you're doing is plugging in. So h of x is the integral from 0 to x. Well, in this case, I'm trying to find h of 6. So it's going to be the integral from 0 to 6 of f of t. And whenever I look at the graph here, this is negative because it's under the x-axis. If I did the integral right. What do you mean? Zero, like if you went over to 400? Is that what you're saying? So like this? So these are all going to be set up where it's going to be obvious to you. One of them you're going to have to test the integral, and they're testing to see that you understand the area, positive or negative. The other one's always going to be 0. It always is 0. And then the other one is going to be whatever other sign that you would have to do a sign analysis for. I've never seen any that weren't like that with these. You'll have one positive, one negative one, and it will be obvious when you look at the graph. Like for this one would be positive, and whenever I went through, I guarantee you that the sign that I'd be looking for here, I'd be looking for a negative sign. I'd be in that interval instead. We'll definitely practice with those. Those get very intuitive, but they're easy ones to get once it clicks for you and you figure it out. They're easy points to gain for that. Unit 2, I posted it. It's all posted. Intro to derivatives. 16. A particle moves along the x-axis with its position at time t given by blah, where t. So this is just derivative. But whenever you do the derivative here, you got to remember which variable is a constant, which variable is a variable. So if your x of t is t minus a, t minus b, I did product rule on this. T is your variable, so derivative of this, a and b could be any arbitrary value whatsoever. So derivative here would just be 1. So derivative of the first times the second plus the first. And then what's the derivative of the second? It's just 1 again. So I've got t minus b plus t minus a. It is. So when I do the derivative, this is the derivative of the first times the second plus the first times the derivative of the second. So I got 2t minus a minus b. And then if what did I have to do? When is it at rest? So when does that equal 0? Because it's at rest when position equals 0. I mean when velocity equals 0. So add a and b and divide by 2 and you get t. If I solve this. There, I told you. But it's the first time you've seen them all like this, and that's why. You'll see, after this one, you'll be able to get so many more points. My kids always shine on multiple choice because you practicing so much. You will not go down. All right, 17. 17 I get mixed up. I feel like these are so confusing when they do these this way because it's hard to tell which one's the axis and which one's the line. And in my hurry to finish, because I'm always in a hurry trying to, I would advise you not to rush like that because you make mistakes. I chose the wrong one. I knew what it was and I knew what I was looking for, but again, I wasn't looking at where the x-axis is labeled and chose the wrong one. But it says the graph shows the graph of f, where f of x is, again, if f of x is the integral of g, that means I'm looking at the graph of what? The derivative, right? If f is the integral of g, then that means f prime is g. So if this is f, right? Are y'all following me? So f prime is g. Okay. So which one? So I'm looking for this. I'm looking for the graph of g, right? The derivative is a positive slope. It's a line, actually. So I'm looking for one that has a positive slope. So I chose the line that was above the x-axis because it's always positive. Derivative of a line is a constant, right? I feel like I just confused y'all with everything there. Okay, this is the graph of f. If I want g, I have to do the derivative of this one. This graph is the antiderivative of g, right? So if I want the graph of g, I'm going to have, this is what I have graphed right here, right? So, this is what I have graphed right here, right? If I want g by itself, then I'm going to have to do the derivative of what I have graphed. What's the derivative of a line? It's a constant. And so then I just look, it's a constant. So like if this line, let's say this was 2x plus 3 or whatever it is, the point that I'm getting to is it has a positive slope. Because whenever I take the derivative of that, I just end up with whatever that slope is, which is positive. And that's how I knew to look above the x-axis and not below the x-axis. Does that make sense? Okay, it gets so confusing. It really does. You really have to stop and think about what it is. 18 was the formal definition. That is our limit as h goes to 0. And so what that was, if you recognized it, the function was natural log of x. They were asking you to take the derivative of this at x equals 4.
What?
The limit as h goes to 0, f of x plus h minus f of x over h. This is your formal definition of a limit. That's that difference quotient, right? Gotcha. This was a quick one, just like this. This literally was only here to test to see if you recognized it being the difference quotient.
Oh, I did.
So it, okay, so so if you ever see that, okay, if you ever see that, and 99.99% of the time, whenever you see something like this, it's difference quotient. This last one is always, if there's an x in it, then they're just asking you for the derivative of that. And if there's a number plugged in, they're asking you to evaluate the derivative at that particular point. In other words, this one, because you see how it's log of 4 plus h minus log of 4 over h. That's telling me to evaluate, if this was an x, if it was log of x plus h minus log x over h, then that would just be the derivative of log x, which is 1 over x. But because there's actually a value plugged in there, just start trying to recognize this being that difference quotient. And looking particularly, I always look at this last one. That's my little clue into. What's the derivative of log x? 1 over x, and then if you plug in 4. That's all it's doing. Remember when we learned, whenever that was the way we did derivative before we learned the shortcut? Or in 19, the function f is defined by at which points on the graph have the property that the line tangent to x, y. Here's where we really start getting into some good stuff here. I feel like once we hit about 17 or 18. I've got f of x. Tangent line. You have to know that tangent line means derivative, right? I found the derivative first because I knew that that was what they were going to want. This was a quotient rule kind of thing. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. And then I said, okay, what do I need to do with that? Well, it says that on the graph have the property that the tan line at xy has a slope of 1/2. So where does this equal 1/2? That's my big question. And from there, it is an algebra problem all day long. X plus 2 minus x over x squared plus 4x plus 4 equals 1/2. And then I just ran through this algebra. I multiplied both sides by, actually I cross multiplied, I think is what I did. X squared plus 4x plus 4 equals 4. If x squared plus 4x equals 0, if I take out an x, I all of a sudden have my two answers, 0 and -4. I don't even have to work that problem all the way out by plugging in because they all have different x's. And I did look at that before I start. Always look at the way your answer choices are formatted so you know before you do too much work. I don't even need to go back and plug it in. Yeah. I didn't go back and plug it in because if you look, none of them have all the same x's, right? They're all different x's. So there's only one that has x value 0. I didn't even have to go back. This in my planning. I gotta figure this out during my planning. Write this down somewhere. My chest is tight. I gotta talk to Miss Brennan during 4 o'clock. Let G be the inverse of F, given that F of 0 equals 1. Now remember, here's what I think about this. Inverses switch X and Y, yes? Okay, so if F and G are inverses, then they always set these up this way. This is the easy way for me to remember them. Find the derivative of F. Okay. And then find the derivative at 0. So in other words, the derivative here, 3 times 2x plus 1 squared, chain it times 2. Plug in a 0. 3 times 1 times 2, so I got 6. You always flip these over when you do this. There's always one like this. I've never really understood this problem, but there's always one in multiple choice. Take the derivative of the inverse, evaluate at that point, and flip it over. Flip it last. Oh, did it still work? Yeah. Because it's inverses, right? So the x and the y are switched. So that's why it's telling you f of 0 is 1. And if it's asking you to find g prime of 1, then if I find the derivative here at 0, and then I flip it over. It's dumb. Well, you kind of didn't. You plugged in this. They told you this because this is, so if I'm talking about f of x, I have the point 0, 1. If I'm talking about g of x, that means I have the point 1, 0. So if I do the derivative at 1 of this one, well, that'd be the same as doing the derivative at 0 here, but I have to flip it. 21, we're obviously not getting through all of these. Okay. The line y equals 5 is a horizontal asymptote to which of the following? I found it odd that this was on here because this is a algebra 2, maybe pre-cal problem all day long. This is top heavy, bottom heavy, same. They're, especially for the rational on the end, right? That was the very first thing I looked for. And that E is same. 20 divided by 4 is 5. Okay, that's only whenever it's polynomials over polynomial. And that's a sign, so that wouldn't matter. Yeah, and that one doesn't have any horizontal lines. And in fact, the only ones that even have horizontal asymptotes on here are B and E. None of the others would even have. Actually, I lied. C has a horizontal asymptote at y equals 0. B is just a line. All right, let's look it up and keep it going. Keep it moving, keep it moving. Ooh, I have a star by 22. Let f be the function defined by f of x equals log x over x. And it asks for an absolute maximum value. Now, I underlined value. Why would I underline value? They're talking about the y. They're not talking about where does it happen. They're talking about what is the value. So as you go through this, what did the derivative? Derivative of the top times the bottom minus the top times derivative of the bottom over bottom squared. I want to know where this equals 0. It doesn't matter about the bottom here because that would force it to be undefined. So I'm looking at where the top equals 0. So where does 1 minus log x equal 0? So where is log x? 1, i.e. both sides. You could probably figure out, since this is the only potential point here, that that's going to be my, well, maybe not. Okay, so when a fraction equals 0, you only look at where the top equals 0, because where the bottom equals 0, it makes it undefined. It wouldn't give you a 0. So when you have a fraction equaling 0 and you need to solve, you literally just look at the top part. if you plugged in here, going back, remember the derivative is telling you what the function itself is doing. The bottom of this derivative is always positive, so I only need to look at the sign at the top, which is here. If I plug in maybe 1 minus log 1, which is, log 1 is 0. I get positive. Anything bigger is going to shoot me into a negative number. So my maximum is occurring here, but again, it asks me for maximum value, not where does it occur, but maximum value. So I have to take it one step further. Luckily, E was not a choice there, so you couldn't mess up on that part, but you do have to plug it back in. The f of E is log E over E, which is 23 asks you if the size of the population, which of the following differential equations describes linear growth, but it's the derivative. So if you have a line and then you take the derivative, what are you looking at? Just a number, just a constant. So it was A. You didn't even have to do it. That was a boom, 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 and done. 24 was tough. Let me show you the setup for it. I'm going to push forward so we have time. I at least want to get through A. G of x is given by x squared e to the kx. K is a constant. For what value of k does it have a critical point at x equals 2/3? So this is, I want to know when the derivative equals 0, but I'm going to plug in 2/3 here. So derivative through the first times the second plus the first times derivative of the second, and I do have to chain this because that e has an exponent there. And so what I did at this point was I just went ahead and I said, okay, I know it's going to be 0 at a critical point, and I'm going to plug in 2/3 for every one of these x's. 2/3, 2/3, 2/3, 2/3. And then I solved it for k. It was a tough solve because you ended up having to factor out, and it was kind of tough. What I would do if I was pushed for time on this one and I couldn't figure out how to solve it, I would start plugging those points, those values in for k to see which one would give me 0. For the sake of time, I won't work that, but I do have it here if you want to see it, so you can see how it's worked out. But just so we have enough time to at least touch on all of these. Which of the following is a solution to the differential equation dy dx equals 2 sine x with the initials? So this is one where we get the dy and dx separated and we integrate on both sides. You end up with a c, but you have an initial condition there. So the antiderivative, let's see. You had dy dx. Oh, I'm out of time. You didn't? Oh, you did. I'd pull the 2. I know we would have. I'd pull the 2 out. It's always a push to get through a practice test when we go over it on Monday. But it was easy. All right, those last 3, I'll run over quickly with you another time. But I hope you feel better about that you did know how to do it. It's just seeing it in this format. If you will put everything in the folder back for me, you can leave the folder there and I'll grab it.